Anyways, hi. So my name is Kalyan, and I'm an assistant professor at Ashoka University. Um, and thank you, Professor Prabhakar, Dr. Sharda, and Dr. Tinano for inviting me to deliver this lecture. There is a formatting issue, as you can see on my first slide. So if you cannot read, so the first one is, does a single model fit all? And then you can read the rest of it. So, okay. Yeah, sure. Okay, thank you. So my specialization is lipid residues and stable isotopes. However, I'm not going to talk about that in this presentation. I think I have spoken enough about it. But I will be talking about unstable isotopes this time and radiogenic isotope, obviously. And how does that might help us to understand some of the aspects of Harappan or Indus Ghaggar-Hakra civilization. Okay, the diagram on the left, many of you are definitely much aware of this diagram. It's a very famous diagram by Clark, and it basically defines how he defined culture as a system. So, culture has multiple parts, and the parts are in an interactive model, and change in one part would render a change in the other part as well. So, in turn, it will change the culture. So basically, the environmental adaptational model, which is highly used, but at the same time heavily criticized for multiple reasons, and I'll cover some of them. So in a very simple way, environmental change would lead to adaptation by human. At the same time, there is resistance and resilience, and in turn, that would change the climate. So change the culture. So that is kind of a general understanding of how this environmental adaptation model works. It's a very simplistic explanation, but when we are talking about culture change and human interaction, we have to remember that this interaction is not very simple. Okay, humans are not the passive recipient of the cultural system, but they're the active participants in engaging with the system, engaging with the change, as well as resisting and resilience. So it is a very complex process, and it's a very simple deductive method is not ideal or suitable particularly to understand cultural change, especially when we talk about how Harappans have declined over the years, right? So environmental adaptational model is a very widely used field. It has its merit. So it's not that, like, don't take me wrong, that it doesn't have its merit. It has its merit. And like many other parts of the world, and it's a very strongly used model, and in many other parts of the world, in the civilization has also been a part of this sort of interpretations, right? So we have seen this map multiple times, so there's no need for me to go over this map, but it's just to highlight the kind of area that I'll be mostly focusing about, and that's the lower region of the Indus civilization, the modern political boundary of Gujarat. So, but before we understand what actually happened to Harappan civilization, how things got changed, it's very important that we create a very robust chronology of the civilization. We have dates, we have multiple dates from multiple sites, but are those dates enough to get a very rigid or very strict or very robust chronology of the Harappan civilization? Now, in terms of Gujarat, there is one site which, after so many years of work, I think has provided some way better data, and that's the site of Kanmer. Not because the site, like a very few Harappan sites in Gujarat was occupied for the longest period of time, but it also had the maximum number of radiocarbon dates, both AMS and the C14 dates. So creating a model would have been better from a site where there are multiple dates versus from a site where there are few. Now, in terms of Saurashtra, we are not lucky. That's partly because there has not been any recent excavation in Saurashtra, so most of the excavations are kind of restricted in the Kutch region. At the same time, there are not much recent AMS dates from Saurashtra, so we only had to rely on legacy dates, and that's primarily coming from Rojdi, and I'll discuss some of the problems of that as well. So in order to create a Harappan chronology at Kanmer, so I have used an open access software, that's Oxcal. It's developed by Oxford and kind of maintained by Oxford. It's open access, anybody can use it, it's fun to play. So that was what I did during 2020 and 2021. That was my Corona project because all the labs were closed, so I couldn't go to any lab and do my lab works. So this is what I have done. Now, there are certain problems that I faced when I was trying to create a model of radiocarbon dates from in the civilization. Firstly, obviously, there is limited information available. Not a lot of dates are available, so it's hard to create a model. And then, especially for Kanmer, there are dates, but again, there are multiple problems. Is that there is no Harris matrix of the site. So, there are some dates from the center of the site, some dates from some other part of the site. There are dates from multiple locations, so we don't know which layer is younger, which layer is older, if there are any connection between layers. So, it created a lot of problems. So at the end, I had to give up on many dates, so I have to focus on certain dates that are kind of in a sequential order. Okay, and then because the dates were not done in a very systematic way, so I had to use multiple models, so I could not rely entirely on one model, and only the model, the outcome where the agreement rate was over 80%, we have only selected those dates and those models, so anything below 80% was not selected for this particular study. So as you can see, these are the dates. So out of many dates, these are the dates that could be easily plotted using the software. As you can see, there are two dates that are marked on with red. Over there, I don't have a, does it have a pointer? Oh yeah, right there. So there are two poor agreement dates. So there is one here and one here. So these two dates were eventually removed from the model so that the overall outcome is not below 80%. As you can see, the overall outcome is right here. So now it is at 41%. So after removing these two dates, we kind of got to the 80% mark. So now this is the final model after removing this dates. Now there is still some disagreement for one particular sample, but that's 54%, which is closer to 60%. So that's fine. It's not a big problem. And now when we modeled the dates, what was very interesting to find is that the beginning of phase 2, which is the mature phase of Kanmer, and the beginning of phase 3, which is obviously the late Harappan or the Sorat phase of the site of Kanmer. Now, as you can see, the boundary start as Kanmer is kind of has a very wide range just because there is no a priori information. So we have a date that kind of post-dates the event, but then we don't have any date that predates the event, right? So now why it is important to have a model is just because when we do radiocarbon date, we have to remember that the starting of the site is not when the charcoal was burned. Okay, so not the first day you enter to the site, let's burn a charcoal, keep the charcoal for archaeologists, they will find date and they will know when the site was first occupied. No, it's not the case. Also, at the same time, when we are dating with charcoals, the biggest problem is the old wood effect, right? Because we don't know how old the wood is, especially when the wood is not identified. So it could be firewood, it could also be a broken furniture of my great-grandfather, right? So those are some of the problems, and that's why the modeling dates are very important so that these sorts of limitation could be eliminated. But as you can see, when we have a priori information, so a date that predates the beginning of phase 2 and post-date the beginning of phase 2, we can pretty confidently put a very restricted date for the beginning of that phase, and especially the beginning of this phase, okay? So now we know when the mature Harappan started at this level and when the late mature Harappan started, okay? And as you can see, there are 3 phases, and then, okay. Now the late Harappan phase, so there is a late Harappan phase at Kanmer as well. I could not model that, it's just because the dates are so dispersed between different areas of the settlement, and it was very hard to model, and we don't know like which date was earlier, younger, which date was older. So we don't have the late Harappan phase at Kanmer right here. Okay, so now interestingly, as you can see, the beginning of early mature phase at Kanmer is around 4400 to 4300, right? But look at the beginning of Sorat Harappan phase, that is 4300 to around 42 to 4100. Now that coincides with a global dry climatic event, which is known by various scholars, and then that event has been penalized or for being the most notorious event that have kind of declined multiple civilizations around the world. So there is an idea similar to that. However, and that's exactly what's happening also here, is that around that time, so 4200 plus minus 100 BP, was when the settlement of Surat, or the occupation of Surat, actually began at the site of Kanmer. Okay. Now, when we look at the other sites, so now these sites, because we don't have a lot of data, a detailed modeling was not possible, but we have general sense of idea. So the Surat phase at Khirsara also started around 42 to 4100, at Bagasra 44 to 4200, at Shikarpur it's again 4300 to 4100, and even at Kotada Bhadli it's around 4300 to 4100. Now that's very interesting, because if now with the model date we can clearly see that these dates coincides exactly with the global aridification event that we have heard multiple times. Now, let's focus on the site called Kotada Bhadli. Okay, so we have excavated, I have not excavated it, but as a team we have excavated this particular site, and we have got 5 AMS dates from this site. One was before the occupation has begun at the settlement, and then there are 4 dates which were, there are 3 dates which were collected after the occupation has begun at the settlement. So, as you have seen these 2 pictures which were shown by Prabodh, and these are the, okay, and these are the, okay. These are the model dates, obviously. And when we look at the, and this is also the sediment carbon isotope data. Okay, so we have done a sediment carbon isotope data just to see what the environment was around the time the settlement of Kotada Bhadli was occupied. Okay, and we have compared this data of again another sedimentary data from the site of Kanmer, and what we see particularly focus on this area. So this is when they argue the shift has begun, so around 4300, and this is right here. So when the site was occupied, as we can see right here, it was also very highly negative, so highly depleted, which indicates a very much like C3 kind of environment. But then when the site became occupied, we have values which are very similar to the values we see at Kanmer. That's also primarily because obviously the increased cultivation of C4 type grasses, which is millet in this case. Now, when we look into the regional chronology of Saurashtra, we also see a very similar pattern. But as I have mentioned, that it was very hard to model the dates from Saurashtra, because again, there were the layers were kind of all over the place. So now we could only do what is that understand when the occupation has begun at the site and when the occupation has ended at the site. But like different phases, it was very hard to identify. So we know Rojdi around the occupation started, let's say plus minus around 5,000 years. And at the same time, the occupation ended sometimes around 2300 or 2100 Cal BP. Now, these dates could be a little problematic because, again, as I said, the model doesn't work well when we don't have a priori information. So, as we can see, the Rojdi was continued to be occupied throughout those climatic disruption that we generally see, and so as many other sites at Khirsara, at Kutch as well, as we have seen earlier. Similarly, the site of Jaidhak was, the beginning of occupation was around the same time. The site of Babarkot was also around the same time the occupation has begun. Before we come down to this slide, so now the interesting thing is that with this dry climatic event, increasing dryness, we don't see a disruption. We don't clearly see desertation of the settlements. We don't clearly see that population are moving. Rather, what we see, the new settlements are coming out. Old settlements continue to be occupied. There could be some changes, but majorly all the settlements were occupied. New settlements began to appear in the landscape. So say, for example, Kotada Bhadli in Kutch began to occupy around the same time. Then we have Jaidhak, Babarkot. So we can definitely see a population increase rather than a population decrease. Now, with the population increase, I don't mean the population was increased by reproduction, which may not be the cause. It could be the population were moving around the places as well. So don't think it's a population increase by reproduction. Now, so we don't see a clear correlation that, the drying climate caused a desertion or the decline of Harappan civilization, particular in this area. And I would want you guys to focus on something else. So let's think that around that time, 4,200 years ago, not only the climate became dry, there were also a lot of things were happening in Mesopotamia. Okay, those are not climate related. Okay, partially it could be climate related, So when we talk about how Harappans became urbanized, we always we focus a lot about how international trade was important, how goods were moving from the places and places. But yeah, but we don't talk about that when we talk about the decline of Harappan civilization. If you remember, around the same time, around 2100 BC, the Akkadian Empire declined in Mesopotamia. The Ur-3 also stopped to working around the same time. So whether we don't know if the political changes that we're seeing in the area of Mesopotamia, what role did it had in the working of in the civilization. It is very important to think that don't think in the civilization as an isolated civilization only located in the Indian peninsula and had nothing to do with other parts of the world. It doesn't work that way, right? They definitely had context. Now, I'm not saying the Mesopotamia or whatever was happening in Mesopotamia was the responsible factor behind the decline of Harappan civilization, but it could be one of those. It could be a multifaceted effect, and climate may be just one small bump in the road. Now, so we have definitely seen a problem with the dating. Now, we could know much more about this problem when we have much rigid, robust dating. Why are we not getting enough dates? A primary problem is that we are entirely focusing on charcoal. Finding charcoal is difficult. Especially finding charcoal in proper archaeological context is even difficult, right? So I would like to propose using bones instead of charcoal as a primary source of dating. And I have done a preliminary analysis using FTIR. And as you can see, the collagen content of bones and teeth from multiple sites across the Indus civilization are quite good. So if we can think of like 1% is kind of a buffer or a area or a boundary, like more than 1% is good for dating and less than 1% is not. So we can see multiple samples already fail within or more than 1%. So if we can just run some samples with FTIR and then send those samples for dating, we can definitely have much robust data because bones are ubiquitous in the civilization. Anywhere you dig, any layer you dig, any trench you dig, there are hundreds and thousands of bones. So bones could be a great measure for dating. And once we have more dates, hundreds of dates from one archaeological site, now we have AUSU, we're ready to date our archaeological samples, right? More dates means much better resolution of what was happening. So in conclusion, interregional interaction in Gujarat continued. There was no disruption in that. And as many have already said, have discussed that, how things were coming to Gujarat, how things were going out of Gujarat. We also know the work by Randall clearly indicated that during this time, the interregional interaction was like in its peak, like everybody was interacting with everyone. We see traditional region to Gujarat were introduced in the so-called classical Harappan settlements. We know Surat settlement now, we are starting to seeing Surat type of material in the Kutch region. How did it come? Whether through migration of ideas or migration of people, movement of people, whatever the region mean. But there are interactions, right? There is possible shift in plant and animal exploitation, and at looking into the data, the shift is not major. It's not a drastic shift. It's not that they were doing one thing and then suddenly shift to other thing because of the climatic change. There is a slow change, and as we can see, the more exploitation of millets, some more exploitation of wild animals, but those were already there. Emergence of brand new hinterland settlements. We have shown that Kotada Bhadli emerged to occupy around that time, so it was not that Kotada Bhadli stopped occupying at that time. Continuation of regional level craft production. So craft production with the bead or shell continued to be done in that area. This possible dominance of sedentary to semi-sedentary agropastoralism was there because we have identified Kotada Bhadli as a strongly agropastoral settlement, and then a very strong regional level interaction-based arrangement. It is very important to understand, and many people have already argued that it's not that there was a centralized government in the Harappan civilization and everything was controlled from a center, but it was rather, multiple regions independently working and then interacting with the other regions. So this strong regional interaction was very important, and that's why one model to explain everything what was happening within the Indus civilization is problem. We have to understand Indus civilization from its different region that were occupied, from its different people, from its different small areas, right? So that's the problem of having, a bird eye view as well as a very top-down model. So this is what something I wanted to share. This is not that something I'm claiming, but these are some of the problems that we can solve. But also these are some of the thoughts that I want to share with all of you. Thank you.